Assalamualaikum warahmatullahi wabarakatuh. Here is the English version of stereochemistry. In my last lecture, you have learned about stereochemistry. Stereochemistry is all about the 3D properties of molecules in organic chemistry. And now I will give you the example of stereoisomer in stereochemistry. As you have learned in stereochemistry, there are two types of nomenclature. There are cis and trans nomenclature and also E and Z nomenclature. And how to differ both of these nomenclature, here we are. I'll give you the example. And here is the stereochemistry example. As well as you know, there are two ways how to determine the stereoisomer nomenclature. First of all is cis and trans nomenclature, and also we have E and Z nomenclature. And this is the example of cis and trans nomenclature. We are two types of molecules. Both of these molecules are alkane. And how do we know that these molecules are alkane? It's because of this double bond in alkane chains. On the left side, you have the cis stereoisomer, and on the right side, you have the trans stereoisomer. Cis and trans stereoisomer is determined based on the priority of their substituents bound in the atomic center of alkane chains. This is the atomic center of the alkane chains, and these are the substituents bound in the atomic center of alkane chains. As well as you know that the fourth substituents bound in these chains are different, and also they have the different priority, and the priority of each substituents is based on their atomic number. For example, the atomic number of hydrogens is different with the atomic number of the carbon, because the carbon is higher than the hydrogen, so this profile substituent has the higher priority than hydrogen, as well as this methyl and ethyl. It's clear that ethyl it has the higher priority than methyl. And because both of these large substituents are at similar site, that's why we call this molecule is cis, and we define it as cis. So this molecule is cis 3-methyl hep 3-ant, because we have another one methyl substituents on the right side, and the alkanes is defined in the third of C of these alkane chains. But on the right side, we have another molecule that we define as trans molecule. Why we define it as trans molecule? Because the larger substituents are on outside. Furthermore, both of these molecules are stereoisomer. And here, another stereoisomer nomenclature is E and Z. When we use this E and Z nomenclature is when we have more than two types of substituents bound into the atomic center of the alkane chains. And the determination of the substituents priority is similar than cis and trans nomenclature, as well as we know that the oxygen's atomic number is larger than carbon atomic number. So it's clear that hydroxyl substituent is more priority than methyl substituent. And so when we have both of the larger substituents are on the other side, so we define it as E molecules. The name of this molecule is E but 2 and 2O because the hydroxyl substituents is on the second carbon atoms, and also the functional group of alkane also on the same position of hydroxyl. It is on 2 or second carbon. Other one molecule is Z molecule of this pentanoic acid. This is an acid because this is an carboxylic acid. We have the functional group of the carboxylic acid here. That's why we name it as acid at the end of the IUPAC name of this molecule. But in the case of E and Z, we need to define it as Z molecule because Z is similar to cheese, and because of the larger molecule are on the similar side. That's why this molecule is Z 3-methyl pent 2-enoic acid. Why we call this pent? Because it has 5 carbons in its long chains. First here, second, third, fourth, and fifth carbon, and these are, or this is the long chains of this molecule, and this long chains consists of 5 carbon. That's why we call it as pent 2-enoic acid. And this is the end of stereochemistry lesson. Thank you for watching.